So what's up mga kachimek? Isang magandang hapon at magandang lalaki sa inyong harapan. No, pero I'm not sure if it's afternoon in your place, so you could be watching this. Pero sana pinapanood nyo yun, no? Nakakapansin ako, paunti-unti ang nag-review ng ating video. But hopefully you are watching, no? Because I don't want to require you to watch it, because learning when we make learning, or when we force someone to learn, no, it defeats the purpose of learning being fun. So hopefully you can find, no, in your comfort of your houses, in the comfort of your home, the fun in chemistry. No, though it's a bit difficult, it's a bit technical, no, hopefully you appreciate the importance of this one. And with that, no, as we proceed with our lecture series, so again, we are shifting from laboratory in lecture. So, in this session, in this recorded session in particular, we are going to talk about chemical bonding. But before, again, proceeding with a new topic, we have to recall first, no, the concept of ions. And then we have to define what chemical bonding is. And then try to identify some cations and then ions that easily form these compounds, or these chemical bonds. And then later on, the fun part, I suppose, and hoping it would be fun for you as well, is you'll have the skill, no, or you'll acquire the skill on how to write chemical formula with some ionic compounds. And on the next session, we'll try to do it by naming and writing the chemical formula of the covalent compound. So this is what we're going to talk about right now. So without further ado, let's get it on! Alright! Ayan na naman ang ating transitional word na alright, kasi mga tinista tayo. So, for the first objective, again, we have to recall what an ion is. And hopefully you can still remember our discussion on ions, no? Ions are atoms that are charged, diba? We said that normal elements, or elements in particular, have normal atoms. No, what do we mean by normal atoms? Normal atoms are atoms that are neutrally charged, or we simply call them atom. Paano sila nagiging neutral? They become neutral when the number of protons is equal to the number of electrons. If you can still recall, a neon, favorite number 10 ko kasi favorite number ko kasi ang 10. That's why I've been using neon, kung napapansin nyo. So si neon is atomic number 10. And it would tell us the number of its protons, which is 10, and the number of electrons, which is 10. That is if it's an atom, no, or an element with an atom that is electrically neutral. But we now learned that atoms don't want to stay as neutral as they should be, because they want to achieve a certain criteria, no, what we call the octet rule, having 8 outside electrons, no, or 8 valence electrons. And when this occurs, no, we call the atoms now ions. And we learned that we have two different kind of ions, no. I keep on reiterating this one because, again, learning when being repeated, no, or topics when they are repeated, we master it. Hopefully, no, we can master it. So cations are the one that are positive. No, usually these are your metals that tends to give up their electrons. Sila yung mga mapagbigay. No? They are generous. Ibibigay ko ang sarili ko para makompleto ako. Parang gano'n. No? I'll give something, yet I'll be full. I'll be satisfied. On the other hand, those who are receiving electrons, no, those are gaining, na medyo madami na nga din sila. No? They keep on accepting. No? Give me more and I'll be satisfied. So these are your anions, no? Cation, cat is pusa, so positive. Anion is a negative ion. So hopefully you will not forget that mnemonics, so that you will not forget. And we learned that we use the superscript on the upper right corner of every chemical symbol to indicate what is the charge. So So, halimbawa, eto si He with 2+, meaning it released 2 electrons. On the other hand, si Mg naman with 2+, it released 2 electrons as well. So, that's how we determine. Paano, sir, pag negative yung charge? We have learned as well that if the charge becomes negative, meaning it accepted an electron, no, or it added an electron in its atom, making it an ion, no, an ion. Alright, hopefully you can still follow. And again, they are doing this to obey the very certain rule, no, or very specific rule, the octet rule. They want to be as stable as the noble gases, and that, except from He, can only be achieved if there are 8 surrounding electrons on the outermost shell, which we call valence electrons. No, kailangan nila ng 8 valence electrons. And by that rule, we have learned that the elements, no, are arranged in a group for a reason. Diba? We learned, let me use one good color here, and let me use this digital pen para hindi ako mahirapan, pero sana magaling. We learned that group 1, char lang, walang tinta. Eto na, yan, galing. Group 1 has their 1 valence electron, meaning hydrogen, lithium, and sodium, potassium, rubidium, mga pababa, they have 1 extra electron, no, or 1 valence electron, or 1 electron in their outermost shell. So, usually, when they release this electron, they become positively charged. So, ang nagiging charge nila is 1 positive, usually, or most of the time. Now, there are special cases which we are not going to discuss. No? Those are forced ionization. On the other hand, no, moving to group 2, this becomes 2 positive because they will release 2 electrons. So, hopefully you can follow. By the way, in group 1, we no longer indicate the 1. Diba? You don't see H1 plus or Li1 plus. You simply say Li. And then we skip this transition group, no, because they serve a special rule. No? They follow a special rule in... Yan, na ano ka? Nagsha-shake. Sana all. Na-stroke check nga natin. Or nag-palpitate. Nag-epilepsy. Anyways, again, they follow a certain rule that we are going to discuss after covalent compounds. Well, this one, no, this group, so hindi pa sanay si sir sa digital pen niya, gives 3 electrons. That's why it should be 3+. Si group 4 naman, carbon pababa, they usually share electrons. So, we'll skip that for now because we are talking about cations and anions. So, this your group 1, 2, and 3 are your cations. Your atoms releasing or losing electrons to become positively charged. On the other hand, ito naman yung mga tagatanggap. Si nitrogen would receive 3 electrons, making it 3 negative, while the oxygen will get 2 negative. Alright? Sige. May nang tinta ang aking pen. Mas maorag pagaro ang mouse, no? And then, this is your 1 negative or simply negative. Now, as they move forward to closer to the noble gases, no, they tend to need lesser electron. Diba? Si fluorine, they only need 1. Si oxygen, si sulfur, and so on. Hopefully, you can follow. They need 2. Nitrogen, they need 3. So, these 3 groups, no, the 5, 6, and 7. So, these are, don't be confused. This is your group 5, 6, and 7. These are your, yan, walang, ang hirap naman ng pen. Kaya believe ako sa mga AVFX din. Mga illustrators. Anyways. Ayan na. Nag-error na. So, 5, 6, 7. These are your electrons. Ayoko na tong gamitin. Magmamouse na lang ako. So, 5, 6, and 7. They are your anions. So, 1, 2, 3 cations. 5, 6, 7 anions. Right? Again, to achieve the noble gas configuration. Now, how do we use this idea? Now, again, you can use your periodic table. Usually, we create our own periodic table. Para hindi confusing, nire-remove namin yung part na to. Yung part na to muna. kapag we are dealing with ionic bonding para ilalagay lang namin yung necessary na elements that will be involved in the production or in the chemical bonding, no? But it's up to you if you're going to obey this, or you simply download your own periodic table, no? Because again, the ions are very important for our next topic, and hopefully you've been refreshed, no? The actual event happening when we are ionizing an atom, no, or an atom is being ionized, is that say for instance this element. How would we know what element it is? So we simply count the number of electron, because it will tell us the number of proton, it will tell us the atomic number. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 electrons, no? 11 ang electrons niya. So check your periodic table again para ma-review pa din. Therefore, I can say that there are also 11 protons. The atomic number, which is represented by Z, is also 11. So my element in atomic number 11 is none other than your sodium. Very good. Yan, wala yung mag-i-edit para sa akin. So wala itong yehey. Ako na lang mag-yehey. So sodium, it is. No? This is your element. Now, in an element, as I've mentioned, no, we have the valence electron. This is your outermost electron, or your electron in the outermost shell. So don't be confused, because we have three kinds of electrons. The inner electron, or the core electron. Ito na yun, including the first and second one. So this is your inner electron. Hopefully nakikita nyo yung movement ng aking cursor. So inner electron, this is your outer electron, or the so-called valence electron. Once it has been removed, it becomes a free electron. So there are three kinds of electrons: the core or inner electrons, the outer, or more known as the valence electron, and then the free electrons. Now, how do we create a free electron? So this is now what will happen. The sodium wants to have 8 valence electron outside. I've mentioned it. So he has two options, no, if that sodium is a guy. No? It has two options. Either you fill in the outermost shell with 7 electrons, or you let go of this one so that the second shell would be your outermost shell. So ito yung dalawang option niya. No, it would be too taxing to wait, 'di ba? Mag-aantay pa ako ng 7 electron kung pwede ko namang bitawan yung isa. Sounds familiar? It's up to you kung paano mo siya i-relate sa real life. I've thought of some char. So, binitawan niya na lang, sacrifice, no, for the betterment of himself. So, nilet go niya ang nag-iisang valence electron. So, suddenly, yan. This now, once a valence electron becomes a free electron. So, meaning, it's not attracted to anything. It's not attracted to a proton in particular. So, your free electrons are responsible actually for our electricity. No? Those are electrons running. No? Free electrons. So, ayan na. Naging free electrons siya for a moment until such time that an anion will capture him, or the electron. I keep on using him on her, on electrons. So, that is the process of ionization. Now, how about chemical bonding? Now, what is the relationship of ionization, or making an ion out of an atom, to a chemical bonding? So, this is the gist of our topic right now, because for the past few minutes, we have just been reviewing and using the review as an introduction for this one. So, what is bonding? Now, what is bond? Now, is it you and your jowa, hindi nakakapag-bond kasi pandemic, or is it the script, my favorite band? So what is bond? Now, it's not your mighty band, Sir Jello. It's not your typical James Bond, no. It's not your Coupon Band, ulit, Sir Jello. But rather, no, I would like to emphasize this one, no. There are two definitions of chemical bond: oftentimes, when students hear the word chemical bonding, they automatically think of a compound, no? They automatically think of a chemical formula. But to mind you, chemical bonds also describe, or is also being described, or also being used to describe the force that holds the atoms, no, together, no? A proton and an electron as their chemical bond as well, no? But more importantly, no, as a highlight of our discussion, the chemical bond that we are going to talk about right now is the attraction between a positive ion, which is our cation, and a negative ion, no, which is our anion, through either giving an electrons or pwedeng sharing of electrons. So we will focus first on giving of electrons. So ignore muna natin sa sharing of electrons. So when we talk about giving of electrons, we are actually talking about the ionic bonding. No? A metal, a cation, will give an electron, and then an ion will receive it. No? We give, we lose, and some will accept, some will take. No? May giver, may taker. So it's a one-way process. No? The metals will give something, the non-metals will accept it. So this is our ionic bonds, no, where the ions are actually bonding. Ba ang talino? Ang galing. So we have two concepts, no, in understanding the covalent bonding models. First, again, repetition na lang to. Only the electrons outside the shell, no, in the outermost shell, or the valence electron, are participating in this kind of sharing. So walang pakialam yung mga core electrons. They don't actually care, you know, what's happening. But the essential ingredient for a chemical bond to occur are your valence electron. And that is to be determined by their group number. So sobrang dali na. Second, so ito, again, these are your valence electron. Group 1 will have 1 valence electron. Group 2 will have 2 valence electron. Group 3 will have 3, 4 will have 4, 5, 6, and 7 will have their respective valence electron in accordance with their group number. No, second, medyo mahabang word to, second and third rather. Yung sa representative elements or transition elements, they have different, no, valence electrons depende sa bonding nila, no, depende sa makaka-partner nila. That's why it's a separate discussion. However, electrons in group 1, 2, and 3, as I've mentioned, 4, 5, and 6, and 7 have fixed, no, valence electron. And then, except helium, they want to achieve the noble gas configuration, no, the 8 valence electron. So this is our periodic table. Now, what I want to focus for you to focus on right now is that you have to remember that all in group 1 has 1 valence electron, and that will release 1 electron, and that will have a positive charge after. Tandaan yon. The group 2 will have 2 valence electron, 2 positive charge, and so on and so forth. Yun yung tatandaan, paulit-ulit. And again, this will not make sense until we put it into practice. So by using our periodic table, we are now going to create our compounds, no, and then write our chemical formulas. So what is actually happening during chemical bonding? So again, let's ionize our sodium. Our valence electron, or our outermost electron, will be removed and will become a free electron for a moment. And there you have it. You create your sodium ion, no, your Na plus ion. Bakit plus lang siya? Sodium is in group 1. It has 1 valence electron. Therefore, our sodium will be like this one. No? You can write it in an atom way, but that's too time consuming. So we simply write Na plus ion, or Na cation. That would do. So this free electron ventures for some period of time until another element, no, particularly in group 5, 6, and 7, will receive it. Mostly elements in group 7 tends to take the electrons from group 1. Diba? Because, eto na, si anion has 1, 2, 3, 4, 5, 6, 7. This is your chlorine, 7. The chlorine needs 8 valence electron or 8 electrons in its outermost shell. The options are again, release these 7 electrons or take 1 electron. Diba? Our universe is so wonderful that it obeys even the simple objects obey human sense sometimes, no. And the free electrons will be attached here, no. It will connect and then okay na, 'di ba? Si sodium has 8 outermost electron, stable as a noble gas na. And si chlorine 8 na din siya, 'di ba? Gusto kasi nilang ma-achieve yung configuration, no, yung pagiging perfect ng mga noble gases, 'di ba? And they either lose something of themselves or gain something from the others, 'di ba? Are you willing to do the same para maging kasing sikat, kasing ganda, kasing ano? Willing ka ba mag-sacrifice ng part of you? 'Di ba? Pwede, 'di ba? But there are consequences. No, akala nila they could easily do it, no, without consequences. But here's the catch now. For a moment, they become stable. But because of the imbalance in the number of protons and electron, di ba naging negative 1 to? And si sodium natin naging positive 1 because it has an additional 1 electron while our sodium has a lesser electron. No, they become partially charged. No, our Cl become negative and our sodium become positive. And behold, the law of physics. It applies to all, no, even in the smallest scale. Therefore, for a moment, they become stable. Yeah, masaya sila. They have the noble gas configuration. 8 outermost electron, 8 outermost electron. But they are now charged atoms. No, they are now ions. And the tendency in physics for unlike charges, they are bound to attract to each other. So your Na positive and Cl negative, both oppositely charged ions, will be electrostatically attracted with each other. Now, this is what we call the attraction, just like the magnets, but within ions, no, electrostatically, because it's the result of their varying electrons, no. Just like your magnets, as I said, where the north and south pole are created, no, or are bonding. And this is what we now call the ionic bond, no? The formation of a sodium chloride, a compound formed from a cation and an ion. And to write that, we no longer write the positive and the negative because you have one positive excess proton here, you have excess electron here, a negative charge. They will balance out, forming now a neutral object, no, a neutral stuff which we call a compound, no, particularly an ionic compound. So let me reiterate that. From atoms we form ions, from ions, no, we form compounds, from chemical symbols we form ions, no, with symbols and charges, and from this chemical symbols with charge, we now form your so-called chemical formula. So that's how we do it, no? We do it best. Char. Na-miss ko lang si Sir Ron. So, chemical formula. Yan. Sige. Sorry ulit sa sulat ko. I'm more auditory. Your sodium chloride. Imagine the wonder of the universe. Diba? Two different compounds from separate groups, no? Hindi sila pinagtagpo, pero hindi lang sila pinagtagpo, no? Tinadhana sila. And that's how we create salt, no, for cooking and for many more purposes. How wonderful the universe is. Thank you, God. Amen. Amen. Amen, mga Chimek. Now, hopefully you are appreciating this one. Sige, let's have another example. Take a look at your periodic table. No? Hopefully you have one with you when you're always watching pala my pre-recorded videos from now on. Please get a pen and paper and then a periodic table ready, either in the internet or an actual one. So si magnesium is in group number 2. How would I know with 2 valence electron? How would I know that? It's because it's in group number 2, or simply by looking at this image, may dalawa siyang electrons on the outermost shell. So 2 valence electron. Si oxygen naman is in group 6. No, because it has 1, 2, 3, 4, 5, 6. 6 valence electron. We don't care, no, in the actual number of electrons in their atomic number. We are after their valence electron, which we can locate via group number. So, wag na kakalimutan yan. Group 2, si magnesium. Si oxygen, group 6. Now, si magnesium would try to release these 2 electrons. Again, let me reiterate, pwede siyang tumanggap ng 6, pero pwede siyang mag-release ng 2. Ano yung mas madali? Obviously, mga kachimik, it would be easier for the magnesium to release 2 electrons. While our oxygen, by the way, the image that I'm using is from Fuse School, no, FUSE School. No, I grabbed it from Google. And then, si oxygen would either release 6 electrons or accept 2 electrons. So again, by logic, by common sense, or by simply, as nature would tell them, the oxygen would want 2 electrons. So as the image will move, the 2 will be released, and then, magic, chung! Nakuha ni oxygen yung 2 kay magnesium. And as a result, magnesium, upon releasing 2 electrons, it becomes Mg with 2 positive charge, meaning his protons, or the magnesium protons, is now 2 more than the electrons. While si oxygen, upon accepting electrons, it becomes 2 negative charge. And behold, sala, the law of physics, or the law of God, diba? Whatever you want to believe in, but it's wonderful. The magnesium with 2 positive and 2 negative oxygen are being attracted, no, by the electrostatic attraction. And behold, you have your magnesium oxide. Similarly, your calcium and your chlorine, for your Colgate, for your protection in your teeth. Calcium is in group number 2. You can check that. Now, here's the problem. The calcium would want to release 2 electrons, diba? While the chlorine, 1, 2, 3, 4, 5, 6, 7, it has already 7. So, it only needs 1 electron. Pero paano, sir, na meron tayong calcium chloride na compound, no? 'Di ba? Scientists before believed that I don't know if I've mentioned this already, but the periodic table created by or arranged by Mendeleev was supposedly circular or spherical. Bakit ganon? Kasi pag pinagtagpo mo si group 1 and group 7, they will match to become seemingly perfect for each other, 'di ba? You get what I'm saying? Halimbawa, si sodium, either ma-combine siya kay chlorine or kay fluorine. 'Di ba? Yung mga nasa group 7, kasi isa ang kailangan ng group 7, kailangan din bumitaw ni group 1 ng isa. Moving forward, si group 2 kailangan mag-release ng 2. Si group 6 kailangan ng 2. So perfect pair sila, like si magnesium and si oxygen. But the scientists realized that this is not always the case. There are compounds or there are elements, ions in particular, from group 2 combining with group 7 or group 5. Diba? It's not always that much. But how do we balance their charges? So, ito na. Bear with me, do not be afraid, because learning chemistry is fun and interesting. So again, kailangan mag-release ni calcium ng 2, si chlorine kailangan ng 1. So behold, matatanggal si 2 electrons ni calcium by my magic. Chiden. Tanggalin pa natin, palayuin natin. Chiden. And one more. Chiden. And there you have it, no? Nakalayo na si valence electron, naging na siyang free electron. We now have our calcium, no, with 2 positive charge. Again, either you write it like this one or you simply write it this one, no? Whatever fits you. Pero time consuming yung ganito. Ito na lang. This what is important is you know how to visualize what is happening, no? Even though we cannot see them because they are microscopic. Moving forward, the solution was one chlorine will accept one electron because kailangan niya isang electron lang. While the other chlorine will accept the remaining electron. And behold, diba, nauso ang salawahan. Si chlorine, simply, since it receives only one electron, it becomes Cl negative, Cl negative. And one chlorine would not balance with calcium with two charges. Therefore, hahawakan niya yung dalawang chlorine anion. But you're seeing, para siyang chick boy. Mali yun, mali. Baka men are trash. No, men are trash na nga, dadagdagan pa ni Sir Jello. Sabihin na lang natin na it's the father, no, holding her two daughter walking in the park. Yeah, para mas magandang pakinggan. But nonetheless, hopefully you're getting the point. No. Now, the problem is, how do we write this one? Diba kanina, si calcium and si chlorine, NaCl lang. Si magnesium and oxygen, MgO lang. But this time, we cannot simply write CaCl, but rather we will be writing CaCl2 to indicate that there are two chlorines attached in this compound. So this is your calcium chloride. Alright? Hopefully it makes sense now. Because the charge will not be balanced if there's only one chlorine. That is your calcium chloride. And take note that all of our ionic compounds are neutrally charged. No? Their overall charge is 0 or neutral, making them stable. No? They want to be alone, but they are meant to find someone that will make them more stable. So again, review. Groups 1, 2, and 3 will have positive 1, 2, and 3. Groups number 7, 6, and 5, 1 negative, 2 negative, 3 negative. And then group 4A, no, si group 4 carbon pababa, they either share electrons, no? So we ignore them first. Now let's have some exercise. Char lang. Okay pa ba kayo mga chimek? So again, you have to practice, and for our last objective, for you to be able to acquire the skill, you have to do it. So for the first one, I'll be doing it my own. For the second one, didiretsuhin ko pa rin, sasagutan ko pa rin, pero before I answer it, I'll leave 3 seconds for you to pause so that you can try it in the comfort of your houses, and you can check, no, if you're actually correct, no, or you can correct me if I am wrong, because we are all doing this on the spot. Exercise. Yeah, charot lang. Sodium chloride. No, first things first, when we encounter a compound, we identify first what elements are involved. No, we have the sodium and the chlorine. No, bakit siya IDE instead sodium chlorine? Later on, I'll tell you why. So, sodium chloride. Sige. Sodium, hanapin ko si sodium. This is sodium. It's in group 1. Chlorine, it's in group 7. So, sodium and chlorine. Group 1 and 7. So, balikan ko. Sorry. So, sodium is in group 1. So, pwede na ako mag-shortcut. I know that all in group 1 will have positive 1 and all in group 7 will have negative. Diba? In example ko na to kanina. So, balance na ang charges nila. I need to simply write NaCl for my compound. Take note, when this is now my chemical formula, and when writing the chemical formula, we retain what is the uppercase in both of the elements. So, this is your sodium chloride. But when writing the chemical name or the spelled name, we use small letters. So, don't forget that. And then, we change the anion suffix with IDE. No? So, instead of chlorine, magiging siyang IDE, chloride. Instead na fluorine, magiging siyang fluoride. Imbis na maging nitrogen, magiging siyang nitride. No? this is the simple way. Copy the name of the element of the cation in particular, no, the one who release electron, and then change the suffix of the anion, no, or the non-metal. Sige, let's try another one kasi in-example ko na yan kanina. So, halimbawa, si lithium oxide. So, si lithium oxide, para magkaroon lang ng relevance, ginagamit siya for your glasswares, no, sa paggawa ng mga glasswares. So, lithium, I'll check again my periodic table. Lithium, group 1. Oxygen, group 6. So, seemingly, I have a problem kasi Li, again, pwede ko na lang siyang, pwede mong gawin by dots, diba? Lithium oxide. So, group 6, meron siyang 6 valence electron. So, gagawin ko to in a two-way process. Kung anong mas better. So, ganyan. Mali. Dapat nandito yung isa. So, again, when doing the Louis dot symbol, so, para sa mga artist, pwedeng ganito. Or para sa mga visuals, no? Kung hindi pa nagigets yung positive and negative. Si lithium will release 1. No? Okay na siya. Magiging na tong Li positive. However, hindi pa satisfy si oxygen kasi pag binigay niya to, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 pa lang. So, similar with our calcium chloride, we need another lithium atom, no, to release another electron to become an ion. So, 2 lithium for 1 oxygen. If we want to do it in a simpler way, Li is in group 1, so Li positive. Oxygen in group 6, so it will have a 2 negative charge. Hindi sila balance, so we simply add Li plus so that we'll have a 2 positive charge. Again, for visual purposes lang to. Kung obvious naman para sa inyo, no need to make this. And this is now equal. So, the remaining task for us is to write how many lithiums are there. There are 2. So, we use a subscript 2 and then a subscript, the symbol for oxygen. So, this is your lithium oxide. So, again, this is not as simple as simply writing LiO. Diba? Akala mo, without the knowledge of ions and the ionic bonding, susulat mo lang siya ng ganito. Again, by the way guys, magkatabi to. So, hindi siya LiO, Leo, but rather Li2O. Now, with a subscript 2 indicating that there are 2 lithium. So, for the rest, try it. No? You have your magnesium chloride, important for your body. No, pag nawalan tayo ng magnesium, Doctors Foster and Smith, magnesium chloride, ladies and gentlemen. Nag-networking. So, you may pause, do it. So, I assume you paused, pero kung hindi mo pa naintindihan, let me again try this. Or kung na-solve mo, let's see kung tama ang nagawa mo. So, first, locate where it is, magnesium oxide. Diba? MgO. Ginawa na natin kanina, diba? Without noticing, di mo napansin, sinolve mo pa rin. So, magnesium is in group 2. So, 2 positive. Hindi ko na iluwi that symbol. O2 negative. Balance na ang charges nila. So, we don't need to add any other elements, no, or any more number of elements. That becomes your MgO. Your my bad. It's chloride pala. Antok ka na, Sir Jello. Sige. Sorry guys, it's magnesium chloride. Sige. For sure, tinawanan nyo ako doon, no? Or nagsasalita kayo, pero syempre hindi nyo ako mako-correct. Kasi hindi ko naman kayo maririnig. Sige, balikan natin. It's not oxygen, but rather chlorine, which is in group 7. So, chlorine with negative 1, hindi siya balance. So, either we add another magnesium or we add another chlorine. But obviously, our magnesium is greater, so we add another chlorine. And this will make it 2 negative, 2 positive. And there you have it, a balanced charge. But you have 2 chlorine, so we write MgCl2. So your magnesium chloride is not MgCl alone. It's wrong. But rather MgCl2. Now, if you're getting this, you're becoming a chemist. Already. You're already a certified CHIMEC. Sige, let's try potassium nitride. Now, for fertilizer, this is for your gunpowder, for your fireworks, no, many applications. So that we are not blindly writing chemical formula. Potassium, K, group 1. And then, fluoride. Ano nga yun? Ay, nitride. Potassium nitride. Nasa group 5 siya. So, hopefully, you can still follow. Potassium group 1, K. Nitride is in group 3. K3. Alright. So, 3 negative. Balance? Of course, no. Of course not. So, we add another K. 2, 3, not yet. So, we add another 1. And then, there you have it. K3, N3 negative. N3 lang, N3. We no longer, by the way, write the charge, no, when we write the compound. Because they are neutral, no, they are neutral already. Now, probably, as of now, if you're a brilliant student, you've noticed something. Sir, may mas madaling paraan para isolve yung ganito na hindi mo na kailangan isa-isahin yung charges, no, or writing the charges. So this is your first task. What is the easier way, no, more seemingly related to mathematics in solving or in writing the chemical formula of a given compound? So that's your first task. Hopefully you are watching the video. If not, you will not get the first task. So that's your number 1 task. For your second task, si aluminum oxide, no, solve aluminum oxide in your paper, no, be it handwritten, it's fine, or be it in a word. No, medyo mahirap kasi sa word kasi mag-exponent ka. So aluminum oxide, show me your formula with the one that I've been doing, yung nag-add ng elements until the charges are balanced. And if you get task number 1, show me the easier way. So that's your aluminum oxide. That's your second task. And yan, for your third task, calcium fluoride, ginagamit si calcium fluoride to create glasswares, specifically for a microscope, for telescope, and so on and so forth. No? For our side mirrors in our car. So solve for calcium fluoride. So that's your third task. And then, for the last part of our discussion, no, we're going to do it the other way around. No, we are going to name chemical formula and turn them into a compound name. So ito sobrang dali, as piece of cake, as easy as a piece of cake. So first, we have to simply know what element it is, no? Potassium, K. So we simply write the name of the element that we are or of the cation rather. So this is your potassium. Again in small letters. So naka-small letters yan, P. Potassium. And then sulfur. So sulfur is our anion. So we change the suffix with IDE. So it becomes sulfide. There's an old way of writing this one. Ginagawa siyang sulfuride. No? But we don't use that anymore. No? Sometimes, sobrang dali naman kasi it will ring a bell to your ear. This is your potassium sulfide. But this task does not end here. Now, I want you to check if whether the chemical formula is correct. And how do we check that? No? How do we do it? How do we do that? We do it best. Char lang. So, potassium, group 1. Again, i-check mo. Sulfur, group 2. Group 6. So, you'll have K plus and then S to negative. Diba? Hopefully, clear na kung bakit ganito yung mga charge na nilagay ko. And I can already use the shortcut, but since it's your task, I would not tell it yet. No? Baka sa synchronous session na lang natin. tatanungin ko kayo since for sure di ko pa na-checkan yan ng output nyo. So, I'll simply add K plus here to make it work, to make it balance. So, 2 positive, 2 negative. Yan, naglalag na. Sinasabi na ni Loom na mag-stop kayo na kasi lagpas na to ng 30 minutes for sure. Pero yan, sana you're staying and you're learning. 2 positive and 2 negative. There you have it, K2 and S. So therefore, this chemical formula is correct, for potassium sulfide. For your task number 4, answer calcium chloride. So that's your number 4. I said the name already. So this is your calcium chloride. But still write the compound name and then check if this formula is correct or wrong. Now, if it's wrong, write on the side of the name the correct formula. Halimbawa, you think this is wrong, the name is calcium chloride, I'll make an arrow. The correct formula is this one. No, if not, you simply copy this on this side. Hopefully, we're clear. Pang ilan na yan? Pang 5. For 6, this one. What's the name? And what's the correct formula if this one is wrong? 7, 8, 9, challenge to si 9, and then 10. No, it's okay if you can't answer 8, 9, and 10 because I included transition metals here. But if you cannot answer that, we'll do it in our either synchronous or a separate video. And there you have it, mga Chimek. If you have question, feel free to send me a message. Medyo mahirap kapag sa private comment kasi hindi ako nadadirect ng notif sa personal comment. I have to check it one by one. So, messenger, GC will do, or personal message, or email. I will be appreciate that. So, mali yung nag-suggest ako na sa private comment kayo magtatanong. Kasi, it will take me days to locate. Especially there are a lot of notifications. Anyway, maraming salamat mga Chimek. This has been Sir Jello. And sa susunod na kabanata, pag-uusapan natin how to name elements, ionic compounds involving transition metals, and how do we name chemical formulas involving covalent compounds. There you have it. Peace out.